Now that we've learned about multiple regression, let's take a look at the normal distribution in R. And so this video is going to be a little bit different from some of the last ones. We're actually not going to be using any kind of external data for this one. I'm just going to show you how to make normal curves with different sections of the curves shaded, either the left tail, the right tail, or both the left and right tail. Okay, so the first thing we're going to do is we're going to look at the curve command. The curve command basically just draws a curve. And the curve that I'm going to draw is going to be a normal curve. And the way that I'm going to make that is I'm going to use the D-normal command. So the D-normal command is just a function that generates a normal distribution. And it takes three arguments. The first is just what I'm calling here x. This is just a vector of some values that are going to be graphed. If I leave this blank by just calling it x, it'll just fill in the values between the limits that I set. The second value is the mean that I'm going to provide. So I'm going to provide a mean of 0. And the third is the standard deviation of the distribution that I'm going to provide. So I'm going to provide a mean of 0, standard deviation of 1. In other words, I'm going to make a standard normal distribution. And I'm going to use an option with this command, the xlim. This is the limit or the range of values from which the values of x will range. I'm going to make them range from -4 to 4. And so you can think of these as standard deviations in this case. And so I'm basically going to make a normal distribution that spans from 4 standard deviations below the mean to 4 standard deviations above the mean. That's usually sufficient to capture most of the distribution of the normal curve. So if I run that, and if I just zoom out, you can see that R has created a normal distribution ranging from -4 to 4. Okay, so let's go back to our script. Now, the next thing I'm going to do is I'm going to superimpose on one of these normal distributions a set of polygons. And what I'm going to have to do is I'm going to have to provide the x-coordinate and y-coordinate for those polygons. So first, I'm going to make two vectors. One that includes the horizontal or x-coordinates. I'm going to call these coordinates x1. Now, incidentally, this is just an object and the name of the object is cord.x1, which is an arbitrary name. I'm going to make that equal to a vector that includes 3 different values. -4, which would be the value at the very left end of the distribution. This is a sequence that will go from the values of -4 to -2 by increments of 0.01. And then the third argument is basically going to be a value of -2. So this is going to basically later shade the region in the normal distribution from -4 to -2. And this will just be part of the coordinates that are going to be used for that. And then I have to provide a y-coordinate. That is a coordinate on the vertical axis. And so again, it's going to be some kind of a vector, and it's going to have 3 coordinates. It starts at 0, ends at 0, and then it's part of the coordinate is the value of the normal distribution in which the sequence goes from -4 to -2 by increments of 0.01. And so if I run these two together, I'll later pass them into another command called Polygon. And so I'm going to basically create a curve just like I created just a minute ago. I'm going to use the normal distribution passing the x, 0, and 1 option to create a standard normal distribution ranging from -4 to 4. I'm going to use the main option to give it a title. And then I'm going to create a polygon that will shade the coordinates in x1 and y1. And I'm going to color those gray. And when we run those, and we zoom into our resulting graph, we can see that it made a normal distribution shading the region from -2 to -4. And so we can, again, kind of just export that, save that. If we were trying to create some kind of a diagram showing that we're trying to find the area below the mean in the left tail, this is the figure that we would use. Let's say that instead of creating a figure that shades the left tail of the distribution, we wanted to shade the right tail of the distribution. Well, it's really the same. We just have to change the coordinates a little bit. So this time I'm going to pass the following arguments to my vectors. I'm going to start with 2. It's going to go to 4. The sequence is still the same, except it goes from 2 to 4 in increments of 0.01. Same thing is going to be true here. This will go from 2 to 4 in increments of 0.01. And then I'm going to save these as objects cord.x2, cord.y2. And I'm going to create the same kind of curve ranging from -4 to 4. But now I'm going to pass into the polygon the coordinates from x1 and y1. and I'm going to color them gray. So we can run that. Again, making sure that we highlight everything and running it. And then if we just kind of zoom out, we can see that it now created a figure with the right tail shaded. Okay, so one more example. What if we wanted to shade both the right tail and the left tail? Well, again, we're going to run our curve, but this time we're going to pass the coordinates for two polygons. One that includes the first set of coordinates, the other for the second. And this will be basically a two-sided shaded region. So if I run this and I zoom out, you can see that both the left tail and the right tail of the distribution are now shaded. And so I can use any of three of these diagrams in trying to answer questions about which areas of the curve we're trying to find.